to relax it. Will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies. I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide. You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too long, wake up, my love. Please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love. Please don't give up on me.
Linux, Unix, Mac OS, Windows, DOS. Oh God, someone save me. Oh, it's a nightmare. It's a nightmare. When will I wake up? Oh God. Oh, hello. It's nice to see you guys again. I was just sleeping a little bit. I guess I had a little nightmare. I don't know. That was a little weird. All right, let's move on here. Welcome back to 100 Days of Rootkit. Hopefully you guys aren't having nightmares from all of the crazy stuff we have gone over. All right, lots of craziness. And please tell me my internet is working. Oh boy. Not off to a great start. The Rootkit site is not loading. Well, regardless, nice of you guys to be here. If you like what if you're returning, well, hello. It's nice to see you again. If you're new, where have you been? We're already 31 days in. All right, come on over here. You bring your friends. All right, you guys can get in line. All right, don't worry. We'll bring you along for the ride too. Don't worry. You'll catch up eventually. So the Rootkit site, I guess, broke in the last like 10 minutes. So we're gonna ignore that for a second. During the stream, if you like what we're doing and you want to help support us, hey, guess what? We're a non-profit, all right? So if you want some tax benefits, all right? If you want to avoid Big Daddy government, all right, you can go ahead and donate to us. During the stream, we got this little bar above my head, all right? You can help fill up that bar by donating here, all right? Donating here, and when you donate here, you can redeem various different rewards like stickers, all right? This awesome t-shirt I got on right here. Look at this thing. It's epic. And our awesome epic sweater, which I absolutely love. All right, all donations are being matched 1-for-1. So 1-for-1 by anonymous donor who will be donating at the end of every single month. So today is the end of the month, so they most likely will be donating either live on stream or right after the stream. Oh, and look at that, my site is working again. Through the donations, we have certain pillars like streaming for 24 hours straight, shaving my head here live on stream, and the one we don't need to go to, all right? It's all right. I encourage you guys not to hit it. Do not donate for us to get here, all right? That's shaving my beard here live on stream. No one wants to see that, all right? Now, if you go over to our site, over in the blog tab, if you have no monies, all right, that's okay. We like giving away things for free, all right? This is why we ask for donations so much, because we give too many things away for free. We're losing all our money. We're giving away another sweater. So if you come over here to this site, you can fill out your info and its basic tasks like subscribing to our YouTube channel, Twitch, etc., and you can win yourself potentially a sweater. Super awesome, super awesome. All right, if you've been following along with us or want to know how to follow along with us, if you go over to our GitHub, on there we have pinned our cert roadmap for our comp sci certs. All right, complete replacement to a college degree. If you go over here and click on this, you can learn everything you need to know in order to get the cert. All right, nothing's hidden. We want you to do it for free. All right, if you want to pay for it, you know, hit us up. All right, I mean, there's 100 Days of Rootkit you can watch, but for some reason you don't want to watch that, you can hit us up and we can talk moolah. All right, we're right now on operating systems. We're ending up Unix and entering file perm stuff. So let's go ahead and talk about this, shall we? If you guys have any questions from the last couple of days, let me know and I'll go ahead and answer them. I'm monitoring the chat. I see hellos for all around. Hello decisions. Hello Kawaii. A whole month of whoopsies. That's right. Whole months of whoopsies. And get ready for more, which I really liked, which was super awesome in the Discord. Which, if you guys aren't in the Discord, what are you doing? Come on, get in the Discord. All right, you don't want to know where the link is? It's in the description of the YouTube video, or if you go over to our site right here, join. There's a little button right here. You can join the Discord. Super encouraging to see you guys actively trying, breaking, failing, and being successful on things like. Where did it go? Who was it? Evox was out there showing what he was able to do, moving files around from USB drives, which we didn't even talk about different drives on Windows and how to migrate them over. So he was Googling, experimenting, looking through, and figuring things out, which is the big thing. That's the biggest thing I need you guys to take from all of this is Google, ask, discover, try. Just do that. If you do that, you will be a great dev, right? That's the biggest thing, is being able to ask questions, investigate things, find out the facts, all right? That's what I need you guys to be able to do. Awesome. All right, shall we move on? We're gonna talk about some file perm stuff here, and let me discuss my notes real quick in regards to Unix no, I think permission syntax is just referencing the chmod stuff. Let me consult my notes just to make sure I'm not missing anything. Is it going to be, gosh darn it, of course it logged me out. So go ahead and open up your terminals if you can for Ubuntu or any type of Unix-like operating system. Here we go. Awesome. This is what I wanted. So let's talk about permissions in files and how to exactly read some of the chaos that we were seeing on the terminal. So I'm going to go ahead and open up my Ubuntu here. Let's see in this. How are y'all's day going? Anyone do anything crazy recently? Go skydiving? Jump off a bridge? You let me know, all right? Did you break your legs? Hey, sometimes you gotta break your legs, all right? It just happens. I don't know why, but sometimes it just comes up and it's like, all right, I gotta break my legs. All right, let's move on here. Oh, yes. There we go. So let's clear this, ls. All right, we got some stuff in here. So we talked about in Windows how you can look and analyze like who has permissions to a file and what those permissions are, and it's pretty easy in Windows. It visually like displays everything very logically. There's usually a nice GUI pairing. You can do it on the command line also, and it doesn't look like that bad. In the Linux world, you usually don't have a GUI, so you're only dealing with the CLI, and it looks kind of confusing at first to most people. So let's see what I'm talking about. Let's bring out Lisa. Lisa, we need your help. Oh, thank you, Lisa, for coming over here. So let's go and do an ls tac Lisa, and let's take a look at some of our files here. And we got a lot of gobbledygook information going on. God, this one is so large. Why? All right, I had to make it larger. I don't want to. There we go. I don't want it to be on a new line. Now it looks really weird. Hold on, let me pull it down a little bit. There we go. All right. So when we call out and have our friend Lisa, because this OS comes jam-packed with a bunch of friends for you, we can see a lot of information in here. And it's kind of weird and kind of hard to discern at first. So we need to go over a couple concepts. Now, the, what do you call it? Windows uses a DACL for its access control, all right? It uses the discretionary access control list, and Unix does not, though. Unix uses, do I have it right here? I believe it's going to be, God, now I'm forgetting the term. Group-based, for the most part. It's kind of a hybrid, but it's role-based, all right? Role-based access controls to a kind of an extent. We'll see here in a second. So we saw that there's this gobbledygook right here, all right? We haven't talked about much of it, but the very beginning part we did talk about. This is where you can see if it's a dash, it means normal file, L means it's a link, and D means that it's a directory. That's cool. But we're going to be discussing this info and this info next. So in Unix, there's a concept of the owner of a file, the group owners of a file, and everyone else, all right? Usually called other, all right? So there's 3 assignable things you can do for a file. You can dictate who the owner is. You can give it a group who will have access to that file. and you're able to say what everyone else can do with that file. So just anyone in the world, what they're able to do with that file, all right? There's 3 distinct sections, all right? Very important, 3 distinct sections here, all right? And these are usually categorized as U, G, and O, all right? And we can kind of see that when we dive into the permission stuff here. I don't think LS will have anything on it, but Chmod and Chon will. So let me do LS and see if it has any information in regards to those. If not, do not fear. We are going to check out Chmod and Chmon. So if you want to change any of those things, we can use commands like chmod and chown, all right? What does chmod stands for? Change something modification. And then chown is for ownership changing. Oh, ch is change. Change owner. I don't remember. Those are the commands, all right? Own is for changing ownership, mod is for modifying the file, modifying who has access to it, and the permissions, all right? Big thing to understand there. Those are the big differences, and they both start with ch, all right? Ch, chown and chmod. So if we go ahead and look at the man page for something like chmod, it should have some clarification for us. Here we go. On the symbols here. So let me bring back my stuff. So you'll see that the user who owns it is going to be referred to as U typically. Others in the group, all right, so this is the group, is going to be referred to as G, and then everyone else is going to be an O or sometimes as an A, all right? O or an A can be the other two. It's typically O though. So that's, I didn't like pull those out of anywhere. You can find that in the documentation. Now it comes in play down here below, but before we move forward, you'll see this concept again, brought it up in Windows, of read, write, and execute, all right? Read, write, and execute, RWX. If we cancel here and look, you'll see here some R, W, and X's. That is your read, write, and execute permissions, and that will tell you who has what permissions to perform what. Now we're gonna dissect this a little bit to figure it out. It's obviously not as pretty and easy as the Windows one, but Unix-like operating systems have a very simplistic approach to files and protection against files. It's way less robust than Windows, so that is a pro on the Windows side, but with more complexity is more difficulty, all right? So it can be a little bit more difficult for some of the Windows stuff also to get right. Windows also has some additional permissions like full control and archive, which I believe that is an option status, but it's a part of there. It's a part of it. In this situation, we do not. It's just 3. We only have 3. Read, write, and execute. And not only do we have 3 options, but there's 3 different groups that can have those options. So 3 and 3. Remember, 3 and 3. All right, we're dealing with 3s right here. That's the magic number. That's the lucky number, 3. All right. So moving forward here, if we look at our stuff here, we'll see that this comes into pairs of 3. So there's 9 options right here with a 10th dictating what the type file is. All right. So there is 9 items here in total, 3 by 3 by 3, and they conveniently line up with this one right here. So the first name that you'll see is the owner's name of the file. So QFC9 owns this file. The next is the group. So QFC9 also has a group called QFC9. So anyone in that group will get access to it. And you'll see we're missing a third one. We're not really missing it because it's everyone. All right, we don't really need to write everyone. It's just kind of implied that everyone else is there. So this matches up perfectly with these ones, also in order. The first 3 here dictate what the owner is allowed to do with this file. The next 3 here dictate who in the group, like what permissions for anyone that belongs to that group what they are able to do. And the last 3 are for everyone else, what they're able to do with that file. So if you want to make it so someone doesn't have access to a file, you can just remove all of those. All right, so you can see this file, no one has access to this file, and no group has access to this file. Only the owner has access to this file. Well, in this case, it's a directory. Only the owner has access to this directory, even though there is a group assigned, which there will always be a group assigned. It doesn't mean that group will get access to those items. All right. It's very important to set these correctly, because this is how you can potentially get exploited, or you can exploit things. All right. If permissions are set incorrectly, like read is set on something like on everyone right here, and you don't want everyone to be able to read this, well, you might have just pwned yourself, especially if this was important information like passwords. Additionally, execute may not be desired if you don't want random people to be able to execute certain applications. All right, it may be very bad for your system if they can execute things that are more sensitive. All right, so be aware of your permissions here. Let's see, make sure I didn't miss anything. I don't believe so. So again, review 3s and 3. 3 types of people, 3 types of permissions, or 3 groups in total. All right. First one, owner. Second one, the group. Third one is everyone else. A group can be attached to multiple people. So multiple people can belong to a group. This isn't really that great of an example right here, because this is kind of a one-for-one relationship, but multiple people can have the same group of QFC9. They will get access to everything that group has access to. All right, so be aware of that. So how do we go about changing these permissions? So changing permissions can come with security needs, but most commonly, you're gonna hit the dreaded cannot execute error, right? Where it's gonna piss you off. So you'll have something like my script down here, and you'll try to execute my script. So to execute a script, we type out it like this, and basically you'll get permission denied. This will happen to you a lot, especially if you're transferring files between Windows and Unix, because the permissions do not translate correctly. So that is also something to be aware of. If you're translating or moving files between Unix and Windows boxes and vice versa, or Windows and Mac OS, the permissions on your files will get messed up, which will not be ideal for most circumstances. So you need to double check them. Usually typically they'll get messed up in a secure way where you'll get less access to it, but sometimes it can go the other way. All right, so you need to be aware of that. Going between Mac OS and Linux, permissions don't get messed up because they're built off the same base architecture. All right, so don't worry about that too much. It's mostly between Windows, all right, Windows and Unix based operating systems. So as you can see, my script, which is a script, we tried to execute it, and how you can execute files is if you put a / at the beginning. This is essentially the same thing as double clicking to run something like Google Chrome. When we run this, we get permission denied. And if we look inside of my script, what is going on here? Okay, we put some nonsense in my script. All right, let me set up this, let me remove my script, and let's set this up more properly. So let's go into Vim, and I just removed my script. So if we do an ls, you can see it's gone. So let's go ahead and bring up Vim, my script. All right, we gotta press I for insert mode. Bam, you can see insert down there. Let's go ahead and make a script in here. So our script is just going to be a bunch of bash commands. All right, so the command line commands that we can run, and we want them to run one after each other. So let's put ls right here, and let's just keep it as ls for now. Very, very simple. All right, so when we run this script, it should run the ls command. So if I press escape now, all right, and then do our :WQ to write and quit, we now have this file. Why did all this stuff go? What is going on? My computer's all messed up. All right. All right, cat, my script. Let's verify that we got our stuff in there. We do. All right. If I want to execute this script, all right, I want to execute this script right now, and I say my dot slash my script. You'll see there's a permission denied. All right. This is going to be one of the most common issues that you will run into over and over again in the programming world. All right. Not having enough permissions to do the thing that you want to do. In this case, execute a file. Execution permissions are probably one of the most commonly changed permissions for a developer. Because we cannot run this file, even if we own the file, if we don't give it permissions to. And you can see, if we look at this line right here, we're missing, if the first three here, so after the first one, because remember the first one dictates what type of file it is, or it's the hint of what type of file it is. The next three are the owner and the owner's ability to do something with that file. And you can see here, we have read and write, but not execute. We cannot execute this file. Let me go ahead and check the chat here, see if there's any questions so far. All right, sweet. If you guys have any questions, just go ahead and drop them in the chat and ask away, and I'll answer them as we move forward here. Also, I am in the Discord for Patreon and Discord Premium members. So you can just join and ask questions away in there. So we need to add execute to this. So we can use, that's going to be a modification to the file. If we're modifying the file, then we're going to use chmod. All right, we're going to chmod it. So if we look at the man page for chmod, you'll see that there are two required items here. Mode and the file. All right, mode and the file. And this other word here called octal. You guys are familiar with octal, right? We talked about octal before, right? Remember? Come on, I know you remember. We talked about hex and octal and binary. It's coming back. It's coming back. They use an octal system for permissions. All right. So that means 0 through 7 dictates what your permissions on a file is. All right. Why is it 0 to 7? Great question. All right. Great question indeed. Let's pull up Paint. I know you guys have missed my drawings. All right. It's been too long. It's been what, like a week or something? It's been too long not to have my drawings here. So what's going on here? Let's go ahead and think about it, for example, for an instance. A permission is going to be an octal number, and we have 3 permissions we can set. All right, so let's run this through a little bit here. So we have 3 permissions of octal, which is going to be 3 bytes in what do you call it? In binary. All right. If we look at this, if we draw a line right here and a line right here, look at that. We have one byte of information and some extra stuff here. So maybe this is taking a weird amount of data to classify a file. So we can kind of figure out how much data is being used per file in binary to figure out how a file is getting its permissions assigned. So we can see here that at least a byte, which is right here, and some extra information is being used. And it comes down to 2 bytes of information are used typically for encoding the permissions and the usage of a file. Do we get some more info here? No, we don't. But in regards to these right here that we have, so our 3 right here, so one is going to be the owner, one is going to be group, and then this one is going to be everyone else. All right, so normal users or anyone else. So what's happening here is they're using each binary piece of data as a flag. So if this bit is ever set, that indicates it's a read permission. If this bit is set, this indicates that they have write permission. I guess I should write these right here. And if this permission is set, I did this backwards, my bad. If this one is set, it's read. If this one is set, it's write. And if this one is set, that's execute. All right. So 3 bits, 3 permissions. All right. That's how it was set up, and this is how it's used. All right. It's octal in its design. So what does this mean for you? How does octal get into this? How does it play into this? Great question. You can use octal values to set and remove permissions, because all you have to do now is look and do some of that octal binary to octal math. All right. If we go back to binary, this value is the ones place. This value, if this is a 1 instead of a 0, this will be 1. If this is a 1 instead of 0, this will be 2. If this is a 1 and these other 2 are zeros, this is going to be 4. All right. If you add that all up, that's 7. 0 is also a number we include, and that's 8 different possibilities, aka your octal. All right. So if you want to maybe only give someone execute access, that means you would have a 0, a 0, and a 1, which equals in octal 1. So you would pass that you would want the user to have a permission of 1. If you want them to have read and execute permissions, that would be a 1, 0, and a 1, which in octal will equal 5. So you would say you want to give them a permission level of 5. All right. And if you wanted them to have read, write, and execute, that's going to be a 7. All right. So that way they'll have 7. And you need to dictate, when you set these permissions, you need to dictate what the perms are for the first person, the second person, and the third person. All right. All 3 of these groups at the same time. There are options in here where you can just set one person over the other. There are also options in here that are not coming up. How inconvenient. Honestly, it's better because you should just be doing it this way. There are ways where you can kind of use like attack W or attack R. It kind of previews it here in order to add or subtract a certain permission. This is where it is right here, but we're not going to get into that right now. We're going to talk about the most hardcore part because the other stuff is easy mode, and you need to know this. All right. It's like this by design because this is how the data is actually stored on your hard drive. All right. So when you're manipulating the permissions, this is the numbers that correlate, and this is why the numbers correlate in the weird way they do, because it's linked directly to the underlying binary storage that's used for your files. All right, any questions there? So if you wanted to make a file wide open, you would give the owner level 7, the group level 7, and everyone else level 7, and they would have, the permissions would be wide open. All right, 777. You typically never want to 777 a file. Please don't 77 a file. All right. Bad things will happen to you if you do that. All right. The most you want to do typically is, if you really want to be crazy, you can 775 something, or you can, the most safe bet is to 755 something if you want to try to open it up as much as possible, but still be as secure as possible. If I tell you 777 or 775 or 755 something, now with this new knowledge you have of octal and how the binary data is laid out for each of these permissions, you can now guess what permissions will be set. So 7 means wide open. 5 means, well, we need to dissect a 5 in here. So we got our 4th place right here. So let's remove 4, and 2 can't go into it, but 1 can. That's the remainder. We have 1 left over. So that means read and execute perms. All right, read and execute perms. So another valid one would be 766. All All right. And you could do 722 and 711 and a bunch of different values. And you can basically mix and match all of these together and get various different outcomes. Oh boy. All right. Any questions on that so far? A lot of weird stuff going on here. Let's go ahead and see some of this, see some of the examples of this. What's up, Matthew? Let's go ahead and see some of the examples here of this, shall we? So let's bring in Lisa here. Lisa, help us out, all right? So let's do some reverse engineering, shall we? Let's put on a reverse engineering cap and let's look at this permission right here, all right? This one right there. It says it has read, write, read, and read. What's the current octal value of the permissions? And the chat says, good job, chat. I knew you guys would get this one. So read and write is going to be a 4 and a 2. So that's going to be a 6. Read is a 4. And read is a 4. So that's the current permission on here. All right. And just to refresh one last time, if we man chmod, we can see we need to put in the mode and then we need to do the file that we want to change. All right. We're doing octal. So what we can do now is say chmod because we want to modify the permissions. And we just found out that the current permissions on this are 644. So if we say 644, the permissions should not change at all. They should be exactly the same. And if we say my script, press enter, it was successful, nothing printed out. And if we bring out good old Lisa here again, Lisa, come over here, you'll see the permissions are exactly the same. So if we want to make it so we can execute the file, how would we go about that? Does anyone want to answer here real quick before I give away the answer? What should we do in order to give this file execute permissions? Looking at the chat. I know there's a little bit of latency, so kind of gives a nice little awkward pause between the asking of the question and the responses. Chmod 1? That, I mean, you're not wrong, all right? Chmod 1. Also, I was looking at which area we would add the execute, but we can try it because, hey, we're in the computer world. We can try anything. We can go ahead and try to break this thing. So let's go ahead and try chmod, and let's just put 1 at the very end. So 641, my script. Because remember, whenever we're setting these perms, gosh darn it, whenever we're setting these perms, we need to give all 3. All right, there are options if you read the man page on where you can just mess with one of them. You don't need to mess with all 3 of them, but we're going to go over all 3 to kind of ingrain all of this in your head. All right. All right. So, yep, we're going to go over mobile platforms here next. This is all relevant for mobile platforms, by the way, because they're all Unix based. So all this will work on mobile platforms. So if we change it to, let's say 641, 1 means execute. So we're changing the last one to have execute. And now if we bring out good old Lisa, you can see that we changed the permissions. Our script now has execute. It lost read though. We no longer have the ability to read the file. So if I try to, well, I'm currently the owner of the file. So we'll have to get into chown to kind of see that. But if I was a normal other user and I tried to read this file, I would not be able to. It would be impossible for me to read it because I don't have permission. All right. So remember also that these are not additions to your current permissions. These are completely rewriting your permissions to the new values you set here. All right. These are not additions. These are not removals. All right. These are not additions. These are not removals. Again, these are not additions. These are not removals. These are complete replacements. These will completely replace all of the permissions with what you set here. So if you want also read and write, if we look over to our guide here, if I want read and I want, read and execute, all right, I need to set this, the most significant bit here, all right, which is going to be a 4, and I need to set the least significant bit, which is going to be a 1. So that means I need a 5 in that place. So if I rerun this with a 5, you'll see now that we print out with Lisa, we now have read and execute permissions. All right, everyone tracking there. Now if I try to execute this, let's see if it will work. And it does not. Why? Because we set this in the everyone's place. We're not just anyone, all right? We're the owners. We're the cool ones on top, all right? So just because everyone can execute it, you're not everyone. If you are a owner of the file or a group member of the file, those are going to be the permissions that are used against you. And if you look here, only everyone has execute. Everyone else has read or read and write. So we're only allowed to read and write to this file. We're not allowed to, to execute this file at all, which is a kind of weird place to be in. But other people have extra perms than you do. That's okay though, because we're the owner, so we can go in and change this. So let's go ahead and change this, shall we? Let's say you make, let's say we're trying to change this and get to a good place. But we made an oopsie, all right? We did a bad thing. For some reason, I don't know how you did, but you did. It's all right. It happens to all of us sometimes. But you put in a big old 0, 0, and a 7, all right? 0, 0, 7. Oh, God. Shit. Did I just fuck up this file? Do I not have permissions to do anything with this file anymore? Let's go ahead and do a Lisa. We're the owners. We made this thing. What the hell's going on? We no longer have perms to do anything on this file. Well, you still do. Don't worry. If we try to read this file, you'll see we can no longer read the file. We're screwed, all right? Not too much though, because we own the file, which means we can still change the permissions, all right? This isn't going to stop us from changing the permissions, but now we can no longer read the file or even edit the file, all right? If I try to do a vim in my script, it will pull it up, but you'll see that it says permissions denied and we won't see the actual contents, all right? So, but don't worry, we own the file, so we can just undo our little oopsie here and give ourselves read and write, which is going to be 6, remember, read, write, both these values, 4 and a 2 on the binary chart here. So let's go ahead and do 6, 6, and 6, all right? We're feeling, oh God, what have I done? We're feeling a little Satanistic today, all right? So we're doing 6, 6, 6 today. And now if we go ahead and look at Lisa, oh, phew. I ain't gonna get fired, all right? I didn't lose my fucking job today, all right? It was a close one. Don't let anyone know I'm scam, all right? I got this job because I'm friends with the owner of the company's brother, all right? Give a $100 bill, so I got in, all right? That's how you save your job, all right? So don't worry, if you own the file, you can still edit things after the fact. And the permissions can always be changed. All right, don't sweat about it too much. You can always recover from it. All right, you can financially recover from this one to an extent. Let's see here. Let's see some questionable flat. So the big thing was need the SLE links to prevent root access. Does anyone change the perm letters? Yeah, so you can do chmod that way also. That is a valid way, and so Mr. GFY put in here a different way to use chmod. You can 100% do chmod that way. We're not going to cover it because we're going more through the hardcore stuff, but that is more of the nicer, easier visual way to do it. Alrighty. Let's see if any questions over here. Nope. Alright, so let's continue forward. So we still haven't set our execute yet, so let's go ahead and re-chmod this, and this time let's give ourselves 7. So that way we have read, write, and execute, because we want to be able to read, write, and execute this file. So now that we've done that, bam, now we can execute it. Now, if you have the cool color coding going on in your shell, you'll see that it typically will turn a green color. Green will usually signify that the file is executable. So now if we go ahead and do my script and try to execute it, oh boy, would you looky here, it executed that command we had in there properly, and it listed all the files that we had. That's pretty cool. All right, that is pretty cool indeed. Again, if you missed it, in our script we have the ls command, and when we executed our script, it ran the ls command. All right, this does not have our friend Lisa attached to it, so it didn't give us the full output. It just gave us the quick output of files that are not hidden. Remember, in Linux, anything with a dot in front of it makes it a hidden file. All right, dots make them a hidden file. Now, and remember, the // in front of a file will make it executable. All right, this is how you execute a file. It's the same as if you were to double click something in Windows. In Windows, you don't have to do the // you can just say myprogram.exe and press enter and it will execute it. But Unix is different. Everything is a file in Unix, and we don't use extensions. We use the magic numbers at the beginning to tell us if it's binary or not, but also it's so up in the air. There's no actual restrictions or like guidelines on what you need to do. This is the universal command of, hey, try to execute me. All right, and then it will try to execute. All right, any question here? The sticky bit. Yeah, I think we're gonna be getting into that one next here. Let me double check my notes. Let me see. No, it looks like we are not going to get into it too much, but what he's referring to is there is an additional option you can set on the files. LS-tac Lisa. There's an there's an additional item you can set on these files, which is basically if you want to allow someone to execute the file as sudo, so giving them temporary root access to the file. All right, that's an additional thing you can do with the permissions. Let me see if it comes up here on chmod. There's nothing right off the bat, but it is an option you can set utilizing this bad boy. Also using the octal. Let me see. It's not something you do very commonly. It's more so this is something that you want your DevOps or IT people to manipulate. All right, because if you're setting this and you're setting it wrong, you're really going to be in a world of pain. So I believe we set just a fourth number. I can't remember if it's 7 or not. It's been a while since I've done it. Yes, it was. So now you can see here that this is basically there's S's here, and S's are saying that you can effectively do stuff as sudo, and this is like the different permissions that sudo can have. It's a fourth number that you add to the end here, and that's where that extra data went when I was talking about the 2 bytes of information here. That's where that extra data is going to, is it's going to that last number, that last value that you can set. I'm going to set it back to 0, so we get rid of that red coloring there. Oh god, now I messed it all up. I think it was the first number actually. Sorry, I had it in backwards, so you add it at the very beginning. So let me change this back. There we go. It goes red, very angry at you, and that's the colorful way of the operating system saying, hey buddy, I hope you know what the hell you're doing here, because you could be in a world of pain if you're not doing something correctly here. So don't mess with it unless you know what you're doing or you're trying to explore it for a meaningful purpose. You can of course do it on your own free time. Having a script with the ls command and the ability for people to sudo run an ls command, not that big of a deal. All right, it comes in a bigger deal when you're doing it on other applications. So be wary of it. You can go explore it. We are not testing for it on the test though, right? Because it's not really needed for most developers, especially early on in their career. This is something more your IT or DevOps buddies will be manipulating for you. All right. Any other questions? All right. Let's go ahead and move on to, was there anything else I wanted to cover? Yeah, I guess we'll just cover real quick the other easier way. Where did my notes go? I just lost them. Here we go. So the other easier way, what's more visually appealing, but it's more typing. So people don't usually do it because I can just put 3 numbers here instead. Makes my life easier than having to type things out. Is you can visually say things like, you know, we talked about the groups. There's the owner, there's the group, and then there's everyone else. O, G, and then U or A, all right? So we can do that here. If we say something like U, which is going to be, O, which is going to be, now I'm confusing myself. O is going to be for the owner, all right? And we can say things like U equals, and then we can set ourselves to like permissions for read on my script. And if we press enter, we can see that ran. And if we look, you'll see that we modified the file, and that modified the, not the owner, this modified everyone. So maybe I'm confused for a second. Let's go check out the man page, because if we're confused, the man page will save us. The owner, sorry, the user who owns it is you. Sorry. I need to change this paint here real quick because I wrote this wrong. Act like I did nothing wrong. All right. We don't need to talk about this. All right. It can just be between us. All right. Shh. You don't need to blackmail me. All right. Please don't blackmail me. All right. So U is going to be for the owner. So if we want to change our owner's permissions, we can say U right here and say read, rerun this. So this is the owner. Its new permissions are equal to read. So if we rerun this and we look at Lisa, it's going to rewrite only the owner's permissions to read. All right. But you can also get a little fancy with this, where instead of having to set the whole thing, you can make it so it's just an addition or subtraction. So what I mean by that is if we want to just add right, we can do a +W and press enter. So this will be adding the right permission only. So if we rerun Lisa here, you'll see that we now have the right permission. I'm not quite sure why that rewrote. I think it's because of my formatting. Let's do this with the read. Gosh darn it. I never use this format, so you'll have to forgive me. Is it just a plus like this? Oh, it is. All right, so let's do Lisa. All right, so you can see that was an addition. So the command we ran here was, so equal sign is going to be a complete replacement for that group's permissions. Minus is going to be a subtraction of only what you said you wanted to remove. And an addition will be an addition of only the ones that you want to add. So this is not a complete replacement like when you use the octal version. This is just going to be replacing, additions or deletions of items. So you can see here we added it. If we try to rerun it again, it says success because we already had it. So this is another way you can go and do fine-grained stuff. Additionally, we can say stuff like -read if we just want to remove read on the owner only. If we press run, you'll see that only read now is gone. So that's the other option. We're not going to get into it much more. Be familiar with your octals, all right, and being able to dictate what you set the permissions as there. Let's go ahead and talk about chown. All right, let's man chown. This is how you can change ownership of a file. So you can change the ownership or the group ownership of a file. You make sure there's no questions coming in. Thanks for the help, Mr. GYF. I don't know if you typed that in while I was definitely not confused there for a second. But let's see here. For own. So if you want to, I don't know, maybe you're leaving a company, or you're sick and tired of a project you're on and you want to give it to someone else, or I don't know what the circumstance may be for you exactly. It's, you know, it always depends, but you can change the ownership of a file. But what's more common is changing the group owners of a file. So maybe you can open up or shrink down who owns that file. All right, it's pretty straightforward for the changing of the ownership or a group of a file. You'll say own, and then you'll dictate who the new owner is, or the new who the new group is, and then you'll say which file. So let's go ahead and see if they have any examples here. So right here are some examples. So you can see that we're changing the ownership of you, so the actual owner, to root. All right, this doesn't have the file in here, which I'm kind of confused for. But let's go ahead and look at a couple examples here. So let's bring out Lisa, our good old friend Lisa. She does so much for us. We're not worthy. Let's go ahead and make this script owned. Let's give it to root. All right, let's give it to root so they can have access to this. Now, before moving forward, for the love of God, please make sure you have root access on your box before you do this, because if you are able to, I can't remember if it will just let you give it to root and not ask for a password, but if it doesn't prompt you for a password and you're able to just give it to root, you're going to lose the file unless you have root access, because then you won't be able to retrieve it back because you don't have permissions to it anymore. You don't own it anymore. So be careful on what you're doing here. All right. So let's go ahead and do own. And let us say root and then my script and run this. So changing ownership of my script operation not permitted. All right, so this is protected. So we're going to have to run sudo because we can't give root access to the script unless we are also root ourselves. So let's go ahead and do sudo, and I'll type in my password, and you'll see now it worked. So now if we do a Lisa here, you'll see the script is now owned by root. All right. So there is, at least in Ubuntu, a safety precaution for changing it to root. It won't let you do it unless you are root yourself. So I had to put sudo at the beginning of it so I could become root temporarily to run this command. Again, that's what sudo does. It allows you to temporarily become the administrative user for just an instant. All right. But now we can see here that the file is owned by root. So very neat and cool indeed. And now all we'll have permission wise is going to be group, because we are a part of the QFC9 group, and of everyone. Now we can also change the group permissions of a file. Since this, let's go ahead and do it for, let's go ahead and do it for the same file. So since root owns that file, we need to be root now in order to manipulate it. So we're going to be putting sudo in front of everything in order to become root so we can execute these commands. So let's go ahead and do a own, and I believe the command was colon and then the group and then my script, and let's press enter. And now if we do ls-tac Lisa, you can see the group is now root. So this file is now completely owned by the root user. We have no access to it anymore except for read. And to see that in action, if we try to execute it, all right, we cannot, because we are now in this everyone tier. We're bottom tier garbage now, all right? We can only read the file. We cannot write to the file anymore, and we cannot execute it. Even though it's labeled green and it looks like we cannot, because we do not have permissions anymore. All right, sad day. We lost everything. We lost everything on this one bit. We could never get it back. All right. So if you're asking where the hell the colon came from, Well, my last colonoscopy. All right, not really. I'm too young for that, right? Unless, never mind. I got some buddies who've definitely had too many in their life, and they were under 30. They had a rough life. All right, let's go ahead and relook at Chaon here. All right. If we look here again, remember anything in brackets is optional. All right. So we need to put the file. That is a requirement. If we just put a name by itself, that's going to dictate an owner. If we want to change the group, right here, if you see, we need a colon followed by the name of the group. So this is where the colon came from, is utilizing this syntax in order to set the group. Now there are, it looks like, some other options you can do here for messing with stuff, and then these examples have a bunch of different options you can set. You can also see here root and then root colon staff. So this would be for changing the owner and the group at the exact same time. I'm still confused on what the /u is for or what it's doing here, unless it's changing it for this directory. But I digress. Any questions on that? And I'm out of water, and it's the top of the hour, so you know what? This is a good time to go on break. So if you guys have any other questions, please pop them in the chat. Anything in regards to these file permissions, all right? And then we're going to be moving on to mobile operating systems next, all right? I shall see you guys in 3 to 5 minutes. Alrighty, we are back at it for some more. But before we do, if you like what we're doing and you want to help support the stream, you can head over to this link, which I'll go ahead and post in the chats because I did not deliver this weekend and go through the videos and change everything like I said I would. But there's the link for the donation for donating. And again, we are a nonprofit, so everything you donate, at least here in the US, is 100% tax deductible. All donations are being met for one by an anonymous donor up to 10,000, which they should be donating either in the stream or at the end of the stream. So you guys, regardless, will see it tomorrow come through. And there were various pillars here that we can hit, like at 6K, 24 hours streaming straight, 10K shaving my head here live on stream, and 20K, we don't need to go there, but that's shaving my beard. No one wants to see that though, so we don't need that. Next, depending on how much you donate, you can unlock various rewards like stickers, this awesome t-shirt I got here, all right? Super awesome, look at that. The next biggest thing, all right? And our exclusive sweater, all right? Super awesome stuff. If you have no monies, don't worry. We're giving away another sweater for free. So fill out this information here. Requires no money. Basic tasks like subscribe to the YouTube channel, Twitch, etc., and you can potentially get a sweater. All right. Moving along here, there are some things we didn't hit on, which we are going to talk about real quick before moving forward to mobile operating systems, because this could be important on your mobile operating system also. So, important files and another important command. To change your password is going to be passwd. All right, passwd. I don't know why they didn't take the effort to spell it out the rest of the way, but they didn't. If you type in passwd and press enter, you can change your password. If you want to change the password for another account, please let me out. There we go. If you want to change the password for another account, you can say passwd and then say the name of the other account here, but that user does not exist, so we can't, change the password for that account. But that's how you can go about changing passwords for account. If you have sudo access, you at any time have God tier powers, which means at any time you can change the password of any other users, no question asked. So if I try to change my own password, I have to enter in my current password and then put a new password. But sudo is root, and root has God tier powers, which means they don't need to adhere to peasant rules. They can just change things and will another existence into life. All right, so let me go ahead and type in a new password in here. Bam, cool. Other important files, we talked about SAM on Windows. All right, SAM on Windows is where user information is going to be stored. That's where your usernames and passwords are stored. Keep your SAM safe. Don't allow other people access to it. Monitor it 24/7. If you're trying to break into a system, then find SAM, get into it and break it. That's what you want. That's where all the passwords are. All right. Now, if you're on a Linux box, there is also an equivalent to SAM. Not really. It's more basic because things in Linux are going to be more basic. All right. Where is this information? You can see all users that are currently made on the account in one single file. All right. This is also a little bit confusing. All right. So stick with me. If we go ahead and print out etsy's passwd, passwd is not for your passwords. It's kind of confusing, but it's not. All right. I know it's a little weird. This is all of the users that are on your operating system right now. So you can see there are a lot of built-in users on the Linux operating system. And this follows a format of the user, and then I believe next is going to be groups, and then next is going to be, I'm forgetting what the X is, but next is going to be your ID and the group ID for your user. Various other items you can set, and then The second to last one is going to be where your home directory is located, and the last one is going to be when you log in, what is the default terminal session you're going to get. So I have mine set up, and yours most typically will also be set up, so you get a bash terminal, but you can change it to be just a shell terminal, so that would just be sh if you want. Or if you can set it to no login, so you cannot log in at that as that user. Or if you install some different type of terminal, this is where you would change it. This is also where you would add, this is a way you could add yourself to more groups if you wanted. But the main thing is this is where all of your users are. So you can monitor this, and if there was a new user that got made in here, weirdly, then maybe you should double check your security, all right? PassWD is not where your passwords are though. Interesting enough. So Etsy, everything configurable. PassWD is how you can see users, their groups, the user ID, where their home directory is, and how they're able to interact on the box, or what their default session looks like. All right, a lot of good information there. All right, that's not where your passwords are. Passwords are going to be in Etsy Shadow. All right, so if we try to cat Etsy Shadow, by default, you will not be able to look at it. I mean, that's where passwords are stored. Why would you be able to look at that? The only people that are going to be able to look at this is going to be the all-knowing eye of sudo, all right, or root. So if you are logged in as root, or if you have sudo access, then you can sudo cat to try to read this file, and you can get an output of the passwords for everyone. So you can see that a lot of these do not have any password set. If they have a password set, it will look like this. It's going to be a hashed password, and if someone gets their hands on this, your box is compromised, and now it's a matter of time before they're able to crack your password. So I can't remember if they utilize, I think they utilize salting on these passwords, but we can go ahead and see online. This password is a password you should not set. So some of these, there are a lot of sites out there that will create things called rainbow tables, which are pre-computed password hashes for cracking things. So let's see if there's one out there right now to try to crack this password. So let's see, Ubuntu password cracker. I don't know. Online. Let's see. This is not going to be it, right? No. Online guessing tool. Interesting. Is this pre-built? I wonder if this is pre-built. Hold on, I'm trying to look for something else. It's not coming up. This is not going to have it right. All right, well, as a challenge, you guys can go ahead if you want and try to crack this password right here. I'll go ahead and paste it into the Discord. And I'll go ahead and paste this into the chat if you guys want to have some fun. There's a little challenge, not required knowledge at all, but something that should be mentioned. This is the exact same for mobile operating systems, which we are segueing into right now. Mobile operating systems are going to be Unix based, all right? Which means that their passwords and users can be found in the exact same place. So whether you're on Linux machines or you're on mobile devices, this is where you typically want to be looking for passwords. For iOS, I'm pretty sure this is still where they store passwords. I could be wrong. Things change all the time in iOS land, and I don't stay too up to date in regards to it. But that is something to be aware of. Never change your perms on that file. Remember, all files are just files in Unix, and all of them can be changed and manipulated the exact same way. There is no permissions. There is no like special secret sauce hiding and protecting anything. If you will it to change, it will change. Also, if you will to destroy your box, you can destroy your entire operating system if you want. Windows, on the other hand, by default, have protections in place in regards to removal of your operating system. So if you tried to delete the Windows folder or the System32 folder on a Windows machine, it will stop you. It will not work. If you try to do it as root here on a Linux box, you will be successful. It will work, and you will screw yourself. All right, do not do that. Be careful when you're deleting stuff. Do not delete stuff like crazy, but also know, like, root is God tier. It is arguably higher perm level than administrator in Windows, because Windows also has an operating system user per se, and that will protect you from doing like destructive things that will destroy your computer. But in Linux world, it's very simplistic. So if you are root, you are God, and you can dictate what happens and what does not, even if that means destroying your computer. So be careful. All right, mobile OSs. Mobile OSs, two major ones that are out there: Android and iOS. All right, Android and iOS. Sure, there's the Samsung one, but it's all Android based. All right, what is Android? Great question. Let's go Google it and see what's up. Android is an operating system that's based off of Linux. All right, so they took Linux and they modified it so it's its own different operating system that's meant for ARM. It's meant for ARM architectures. For most of the time, it's best for ARM architectures. That's what it's most optimized for. So that's going to be RISC-based computing, and it works really, really well. And it's optimized for lightweight I am just stroking out here. Holy crap! Lightweight devices. All right, it's its own little custom thing. Anyone can fork this and take it and use it for their own, because it is open source. You can make your own mobile operating system based off of Android. You can go in and take the Android kernel and download it and build your own operating system on top of it, just like you can with Linux. You can take the Linux kernel and build your own operating system on top of it. People do it all the time. People make their own modifications. If you have any other phone besides the Google Pixel phones, you are getting Google Pixel phones have pretty much the most vanilla Android operating system you can get. Everyone else, every phone manufacturer under the sun, for some reason, puts their own special sauce on the operating system to try to make it better. Most of the time, it just becomes worse and more annoying, and it's just cancerous, all right? But you can do it, and no one will stop you, all right? It's completely free. You'll have to check their licenses, but it is completely free for you to use. I think if you're using it commercially, there is some stipulations in regards to the license. Let's go ahead and look. Android, GitHub. Here we go. Here's the entire Android operating system right here on GitHub. In which repo? That's a great question. I'm not up to date on the repo for it. It's one of these repos. Well, this was bad for me to go over here. Fully functioning Android app. That's not what we want. There's probably a better link to it on the actual, what do you call it? On the Android page. But regardless, when you're in here, look through, all right? Look through what is the license attached to it. So you'll see right here, there's an Apache 2.0 license. It looks like pretty much all of them are going to be following that. So if you don't know what the Apache 2.0 license is, that's all right. Click on a repo, then you can click on the Apache 2.0 license, and it will tell you what you're able to do here. You're free to use it for private use, patent use, distribution, modification, commercial use. Your limitation: trademark use, liability, and warranty will not be included, and there are some license and copyright notices. So this is typically, you have to let people know that you're using this. And you have to tell people what the changes are that you did. You can check out more information about this and specifics if you go over, is it on this page? There's a license, let's see, open source licenses. There is a site called, is it opensource.org? No, this isn't it. Hold on. Where is it? There's this really, there we go. Choose a license. This site is super, super nice and sleek. They have pretty much all the open source licenses you can find here, and it lists, in bullet point lists, the super simplified version of each one. So here's that Apache 2.0, and we can click on this link right here at the bottom for the full Apache 2.0 license. Also in the this is also included in the repo. I guess I kind of went over that. I was trying to go to this site first, but right here you can read the actual license and see what you can and cannot do in all the legal glory. All right, let us move on here. So Android is pretty awesome. All right, anything that we've gone over so far will typically work in an Android operating system. How do you get access to that stuff? By default, your Android operating system doesn't really let you get access to the underlying terminal. There are some applications you can download on your phone to get access to the underlying terminal, but it's going to be very limited access. You can run pretty much most of the commands that we've already gone over because it is using Linux. All right. Now, if you want full unadulterated access to your OS, to your Android operating system, you can do that by rooting it. Why is it called rooting? Have I failed you? We've talked about a special user, right? In Linux, goes by the name of root. It's absolute god tier. You can do anything you want, no questions asked. That is why it's called rooting, because you are getting root access on your mobile phone, because you do not have it by default. Now, this can be super awesome because now you have a bunch of extra capabilities. This can also be really, really bad because now you have root access. You've made it publicly available. It's locked down and not available by default, which means if you get malware on your phone, they can potentially upgrade their perms to root access and totally sink into your phone into the very depths of it. All right, not a great thing to have. All right, if you have malware on the phone, so be careful if you're going about rooting your Android phone. Rooting Android phones are relatively easy, especially compared to iOS. It's not too difficult. There's some steps online. I don't know how automated it's gotten right now, but last time I checked it, it was pretty much automated to the sense of you could just plug it into a computer or even visit websites and slide a slider or start an application on your phone, on your computer, and it will immediately start rooting your phone for you. All right. Now, your mobile operating system has a lot of security features built into it, particularly to avoid against malware. These are security features that haven't even made it to your operating systems yet. Operating systems do not even have a lot of these security features, all right? One of them is going to be ART. This is the Android runtime, all right? This allows you to sandbox your applications. So we talked about Docker and spinning up containers, right? The containers are like little tiny mini operating systems that are in their own little enclosed world, isolated from everyone else. Even the networking between containers is completely isolated, and it looks like they're on their own little NAT, all right? Compared to everything else, they're completely isolated. You get that automatically with the Android OS. So every single app that you open is going to be isolated by default and unable to communicate even with the base underlying operating system, all right? A lot of the things they want need to be requested up front in order to get access to it inside of the container. But by default, it's completely isolated and it's not easily able to communicate or jump out of that and communicate with other apps. Now, it's still possible to do that, but it's really, really difficult, all right? It's a really difficult starting place, and it's a security feature that is implemented on your phone, so it's good to know about it because you can potentially run into issues with it also when you are doing mobile development. So it's good to know about ART and that it is a sandboxing feature. That's what they call it in Android. They don't call them containers, they call them sandboxes, so each app is going to be in its own sandbox. Let's see what Google will bring up. If we Google it, art.com, that's exactly what I wanted. All right, Android runtime. Let's see what the Wikipedia page says on it. So you get some nice little pictures here in regards to how it goes about working. You can get some overviews when it was first introduced. And this is a really, really short page. My God. So it might be better or more beneficial after all to just go to the actual android.com page and read about it here. A little bit more information in regards to this. All right. Alrighty. Let's see what was next on here. Side loading. Side loading is super awesome. This is why Apple has had lawsuit after lawsuit and is in hot water with pretty much every governing body in the world, EU, US, everywhere. All right? It's because of something called side loading. By default, in iOS, you can only download applications from one place, and one place only. That is the Apple App Store, all right? You're not allowed to sideload applications on iOS devices. They claim it's a security feature. They're not completely wrong, but they're not right either, all right? So sideloading is the ability to download things without going through the official store. You do this all the time on your normal computer. Have you ever gone to a site and just downloaded something, installed it, and ran it? How about Steam? Did you download Steam through the Windows App Store? No? Then you technically sideloaded it. It's basically what you normally think of as downloading and installing application. You go to a website, you see they have a game, an app, whatever you want. You click on the download button on that website and it immediately downloads it on your phone, and then you click on it to bring up the installer, and then you go through whatever steps to install it. You didn't go through the official Microsoft Store app, all right? This is the first party app that Microsoft has on Windows in order to help regulate and basically bring stability to the chaos the chaotic world called developers in the developer worlds. Because again, where you're becoming a developer, there are no guides, there are no regulations, there are no codes like building codes that dictate how you need to go about securing, building, and creating your application. Developers are not built equally. They are not equal. Just because they have fancy graphics and look cool and are innovative does not mean they are secure or should be trusted. All right? These are all things that are very arbitrary. And as long as they work for the user usually will not question the integrity of the application until it shows up in the news for leaking passwords or doing something else malicious. All right? The Windows Store, Android Store, and iOS Store are there to, first of all, bring income to the companies, but second of all, to put order in the chaos, to be the governing body in regards to these applications, to scan them, verify them, make sure they are doing things they are supposed to, going about securing your information they're supposed to, asking for permissions like they're supposed to, basically behaving well. All right? That's the biggest pro for them. When you sideload, you as the user take all of the risk, all right? You got to make sure you're downloading things, that aren't crazy. So Android by default lets you do sideloading. It's typically hidden behind an option that you need to toggle on in the developer settings, but you can do it. You can go over there, turn it on, and now you can download any app that's not from the App Store. This is also a required feature for you to turn on if you want to make your own Android apps, because you're technically sideloading them onto your phone. All right? So that is a super cool feature of Android that has been there for quite a while, allows you to do more with your phone, and you're not restricted to the Play Store. iOS, on the other hand, it's locked down. You cannot do that. They do not allow for extra features like that. They claim it's for security reasons. They're not completely wrong because it helps with security, but it also forces you to use their system, to make an account through their systems, for developers to have to split their pay with them. So it's not an ideal feature. To be honest, look, Android has never really had a lock system. Like, they pretty much always had sideloading. Apple could just have sideloading available and then advertise and tout the fact that if you use their official app, you have guaranteed like peace of mind because they're scanning everything and making sure things are secure and not malicious. All right. No one really does much side loading on Android anyways. That's kind of a very niche community. So they can avoid themselves a lot of hot water and payments, but they don't. Any questions so far? Now, we called it rooting in Android when you get root access to your phone. In iOS, it's called jailbreaking, all right? Jailbreaking is what they call it, but it is effectively doing the exact same thing because iOS uses the same kernel as the laptops, which is the, wow, God, what is the kernel called? Kernel. I'm forgetting what the kernel is called right now, but they utilize the same kernel. All right. So, and it's all based off of, it's all Unix-like. All right. So the original OS is based off of Darwin, which is a free BSD version. All right. And there's still root. So if you get root access, when you jailbreak your iOS device, and now you're able to do anything you want. You can download anything, you can manipulate anything, you can change things, you can do anything you want. The only downfall for this on Android and iOS is typically when you root your phone, if you update it ever, you will lose your root access, or you will just straight up not be able to update your phone anymore because of certain gateways they have, or what's the term for it? Certain precautions that the mobile developers have on their phones. But those are all things that you can do in regards to mobile operating systems. Any questions on that? Go ahead and ask questions away. Let me double check my notes, make sure we didn't miss anything here. Yeah, the all other thing that you can do that's really bad is when you are jailbreaking or rooting your devices, if you mess it up, you can end up bricking your phone. All right, bricking your phone means that it's pretty much unusable anymore. You can't get it to boot up or load because, again, things are very particular. Remember when we talked about your computer, the BIOS starting, and then it going to the bootloader to figure out what to start next? If any of that information gets just borked, then you're in a world of trouble because a lot of stuff on mobile devices are set almost at the hardware level to be unchangeable. They're not really adapted to change because they're not expecting you to do a lot of these crazy things. So if you change them, you can end up ruining your phone. You can end up bricking it, which means that it literally won't turn on anymore. If it does, it just gets all messed up. Now, just like your computer, your phone does also have a BIOS, all right? Depending on your device, there are different ways to access it, but it's usually labeled as a recovery mode. All right, when you enter recovery mode, that's how you can get access to the quote-unquote BIOS of your machine, and you can manipulate a lot of the underlying settings before booting into your OS. Remember, all these devices are the same. They are all computers. They are all running operating systems, all right? Full operating systems, they all run the same way. They are all a part of the same group. They have the same RAM, CPU, GPU, hard drive space, all right? It's the same logic across all of these machines. So everything that you're learning from everything in the past, networking, operating systems, hardware, they're as applicable to mobile devices as they are to your hardware, your actual computer hardware, laptop hardware, server hardware. They're all the same. They're all built the same. They have the same components. Any other questions before we end up the day today? So tomorrow we're going to get into file systems and operating system processes, and I think that'll probably be it for tomorrow. And then the next day, we'll talk about process internals, then, and maybe get into 11. Then the next day, we'll do device drivers, and maybe finish up with this. And guess what? We're getting close, you guys. We're getting close. Because after that, guess what? After that is when we start getting into programming fundamentals. All right? This is the stuff you guys have been waiting for, all right? So before we get into actual programming, we're going to be talking about the fundamentals first, all right? And then we're going to jump into actual programming, all right? Because if we talk about programming the fundamentals first at a high level, it will help make the actual programming we do more comprehensible, all right? You'll understand what we're doing and how and why we're going about it. Alrighty. Any other questions before we end today's stream? I'll wait another second to see if any questions roll in. Awesome, awesome, awesome. If there are no other questions, then that will be the end of today's stream, and I will see you guys on the next one.